Hello students, welcome back to e-learning Ejo. In today's class, we'll be learning how to find the bond order for different molecules like for oxygen, fluorine, nitrogen, etc. And before moving on to this concept, we need to know what is meant by the molecular orbital as well as the molecular orbital theory. So under this theory, there is particular arrangement and you have already learned, right, how to write the electronic configuration by following the Aufbau principle. Similarly, there is something called as the molecular orbital theory in which it describes how to write the electronic configuration for the molecules. So first we have to calculate the total number of electron, and if the total number of electron is 14 or less than 14, then we will be following this rule, that is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equal to pi 2py, sigma 2pz, pi star 2px is equal to pi star 2py, sigma star 2pz. And if it is having more than 14 electron, if the total number of electron is more than 14, then sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px is equal to pi 2py, pi star 2px is equal to pi star 2py, sigma star 2pz. So first we have to study this molecular orbital electronic configuration. It is very easy. See here, if it is having less than 14 electron or 14 electron, first sigma, then star of sigma, sigma 1s, then sigma 2s, star of sigma 2s, then first is pi 2px is equal to pi 2pi, then sigma 2pz. Then the same thing which is repeated, the thing is that there is star over here, pi star 2px is equal to pi star 2pi, sigma star 2pz. And if it is having more than 14 electron, then see here till 2s it is same, till 2s it is same, sigma 1s, sigma star 2s, sigma 2s, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then after that sigma 2pz will be coming here. That is the only difference, sigma 2pz. Then pi 2px is equal to pi 2px, pi star 2px is equal to pi star 2pi, sigma star 2pz. And now we'll be solving this electronic configuration for the molecular orbital for various molecules. Firstly, I will take the hydrogen. See here, hydrogen, you know hydrogen, how many hydrogen is there? 2, right? So here 2 hydrogen is there. So 2 into, what is the atomic number of hydrogen? 1, right? So 2 into 1, which is equal to 2. And so sigma, the total number of electron is 2. And after getting the total number of electron, we have to write it in the molecular electronic configuration. You know how to write the electronic configuration as per the Aufbau principle for the atomic orbital. Similarly, you have to learn for the molecular orbital. So for molecular orbital, first is sigma 1s 2. Okay, sigma 1s. In the atomic orbital, it is 1s, right? After 1s, it is 2s. Here, sigma 1s. So sigma 1s, in the S, the maximum number of electron accumulated is 2. So sigma 1 is 2, maximum number of electron is 2, so sigma 1 is 2, and bond order is equal to half into number of bonding molecular orbital minus number of anti-bonding molecular orbital. So you need to know what is meant by NB as well as Na. So NB, the number of bonding molecular orbital, is nothing but it is the number of electron which is present in the bonding molecular orbital. Bonding means which does not have the star over here, that is a bonding. And anti-bonding means which has a star, sigma star 1 and sigma star 2 is, these are all the anti-bonding molecular orbital. So here hydrogen 2 electron is there, so sigma 1 is 2. And again the other example, Li2. So here 2 lithium is there, right? So 2 into atomic number of lithium is 3. So 2 into 3 is equal to 6. So here totally 6 electrons should be there when we write it in the Aufbau principle, that is the molecular level electronic configuration. So first is sigma 1s, and in 1s 2 electron, then sigma star 1s, and again in this 1s 2 electron. So totally now it is 4, 2 more electron is required, sigma 2s 2. So 4, 5, 6, totally now it becomes 6 electron. After that you have to find the bond order, right? Bond order is equal to half into NB minus Na. So NB means what? The number of electrons. So in the side you can write, okay, so NB is equal to how much? The electron 2, 4. It is the electron which is present in the bonding molecular orbital. Na means it is electron which is present in the anti-bonding molecular orbital. Again it is 2. So 2 minus 2, So you know that 2 minus 2 is equal to 0, and anything multiplied by 0 is equal to 0. So here bond order is equal to 0, and once you get the answer is equal to 0, you can write the element does not exist or the molecule does not exist. Lithium molecule does not exist. Sorry. Here NB, number of electron in the bonding molecular orbital, is 2 to 4, right? So here it is 4. So 4 minus 2 is equal to 0. 4 minus 2 is equal to 2. So it is 2 by 2. 2 by 2 is equal to 1. So here lithium, the bond order of lithium is equal to 1, not 0. I have done a mistake over there. So NB is equal to 4, not 2. So yeah, so you will be getting the answer is equal to 1. 1 means what? Here lithium molecule, it forms the single bond. So after that you can write it forms the single bond. And again we need to check whether it is diamagnetic or paramagnetic. See here, it is diamagnetic, right? Since each orbital is having 2 electron each, it is diamagnetic. If there is even one electron which is left unpaired, then it is a paramagnetic. So we'll know about it when we solve more example. And again Be2 means it is beryllium 2, right? So here 2 into what is the atomic number of beryllium? 4. 2 into 4 equal to 8. So sigma 8, totally 8 electrons should be there. Sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2. Then after sigma towards 2, sigma star 2 is 2. Now count the total number of electrons: 2, 4, 6, 8. So here 8 electron is there. So after that you can find the bond order. Bond order is equal to half into NB minus NA. So you can write in the side NB is equal to how much bond? 2, 4, 4. NA is equal to how much? NA is equal to 2, 4, right? So 4 minus 4 equal to 0. So anything multiplied by 0 is equal to 0. So bond order is equal to 0, and hence the molecule does not exist. And now we will see for the carbon, C2. So C2 means here carbon 2C is there. So 2 into atomic number of carbon is 6, right? So 2 into 6 is equal to 12. Sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2. Now 4, 6, 8. After sigma star 2 is 2, if it is having 14 or less than 14 electron, we'll be writing pi 2px, right? After this, pi 2px is equal to pi 2py. So care should be taken when you fill the electron in this 2px cells as well as 2py orbital. Will be first singly filling, only after that will be doubly filling. That is as per the Hunt's rule of maximum multiplicity as well as the Polish explosion principle. First we will be singly filling. Okay, so here now 4, 6, 8, 9, 10, 11, 12. Like this we'll be filling. We won't be just putting 2 firstly, because first we have to fill it singly for the px as well as the py. Now the total number is 12, right? So here we will write the number of electron in the bonding molecular orbital. NB is equal to how much? 2, 4, 6, 8. And Na is equal to 2, 4. So here bond order is equal to half into NB minus Na. So NB means it is 8, Na means 4. So 8 minus 4 means 4, and 4 by 2 means it is how much? 2, right? So C is equal to, answer is 2. So carbon and carbon, there is a presence of double bond which in between these two carbon atoms. Okay, so the molecule exists which is doubly bonded, and see the magnetic property, it is diamagnetic because doubly filled, paired, paramagnetic, diamagnetic in nature. And again we'll do more examples. Oxygen. So here oxygen means, here what is atomic number of oxygen? atomic number 8, right? So here 2 oxygen is there, so it will be 2 into 8, so it will be equal to 16. 2 into 8 equal to 16. So here totally 16 electron is there. So we have to follow the Hofbauer principle, right? For the molecular level, sigma first, sigma 1 is 2 electron, sigma star 1 is 2 4, sigma 2 is 2 6, sigma star 2 is 2 8. So it is having more than 14 electrons. So you know, when it is more than 14 electron, then first sigma 2pz will come first. Sigma 2pz 2, then pi 2px is equal to pi 2py. See here, when you fill the pi orbital, that is pi 2px as well as the pi 2py orbital, you have to fill it singly. So now calculate 4, 6, 8, 10, 11, 12, 13, 14, and again 2 more electrons should be filled. So it is pi star 2px is equal to pi star 2py. So 1 1 each. Okay, so now totally it is 16, right? Now totally 16, and now we'll be writing the Nb and Na. Nb is equal to how much? Number of electron which is present in the bonding molecular orbital. Is 2, 4, 6, 8, 10. Na is equal to how much? 2, 4, 5, 6. So bond order is equal to half into Nb is 10, 10 minus 6, Na is 6. So 10 minus 6, you know it is 4, right? So half into 4, which is equal to 2 2. So here 2. So the bond order you will be getting it as equal to 2. So here oxygen, it is doubly bonded. Okay, so here double bond is present in between these two oxygen molecule, and again it is a paramagnetic in nature, right? Because here you can see the 2 unpaired electron, one here and one here. So because of the presence of these 2 unpaired electron, it is paramagnetic in nature. Okay, next one more example, nitrogen. N2. So here in the case of nitrogen, so you know that 2 electron nitrogen atomic number is 7, right? So here 2 nitrogen is present, so it will be 2 into 7, which is equal to 14. And so when we write the electronic configuration, it will be sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2. After sigma, since it is having less than 14 or 14 electron, then we'll be following, first we have to write pi 2px, right? Pi 2px is equal to pi 2py. Now count the number of electron: 4, 6, 8, 9, 10, then 11, 12, and after that total 14, then sigma 2pz2. Okay, so here now total it is 14, right? When we count the number, total it is 14. So here 2, 4, 6, 8, 10, 12, 14. So Nb is equal to how much? How much bonding molecular orbital is there? 2, 4, 6, 8, 10. Anti-bonding Na is equal to how much? 2, 4. So bond order is equal to half into 10 minus 4, which is equal to Half into 10 minus 4 means how much? 6. So 2 3s are 6. So 3. So here n is yeah, there is a presence of triple bond in between these two nitrogen atom, and again it is yeah, it is diamagnetic in nature, right? So you have to write the magnetic property, then the structure of the molecule also you have to write, and how many bond is present in between the molecule. Okay, only then you will be getting full marks. So that's all for today's class, students. So if you have any doubt, you can just put the comment in the comment section. So bye, students.